In this video, we're going to dive deeper into thing descriptions by exploring one of their core concepts, interaction affordances. As we previously learned, a TD serves as a description of the possible interactions with a device or service, defined as interaction affordances. An interaction affordance is one of three types: a property, an action, or an event. An affordance is defined not only by its semantic role, but by accompanying metadata, such as interaction metadata, made up of a data schema describing the input and output structure, and forms specifying protocol bindings. To understand this better, we'll expand on the example from the last video. This is a snippet of the interaction affordances of a smart coffee machine. How an affordance is actually activated, for example, via a network request, will be covered in a later video. Properties define the state, sensor values, or configuration parameters of a thing. They can be read, observed, or written to. In our example, coffee beans left is a property that returns the number of grams of coffee beans remaining in the machine. This property can be read, but neither observed nor written to. Actions define operations that a consumer application can trigger. These are used when something needs to happen within the thing, like starting a process or performing a task. For instance, brew coffee is an action that starts brewing a cup of coffee. It takes an input, the volume of coffee to brew, and is invoked by the consumer. Events represent notifications that a thing emits to the subscribers of the event, often asynchronously. These are used for real-time updates or alerts. In this case, low on water is an event triggered when the water level is low. A consumer can subscribe to this event and be notified when it occurs. This event definition currently has no data field, meaning it simply signals that the condition occurred. However, events can also carry data. For example, low on water could include the exact volume of water remaining in milliliters. Each affordance includes interaction metadata, which provide context about how it can be used, including the following: title and description. These are human-readable labels. Flags, only applicable to properties, such as read-only, write-only, or observable. Subtypes, only applicable to actions. They may be safe, idempotent, or synchronous. This metadata ensures clients know how to interact with the affordance over the network. Alongside the given examples, there are additional, more technical forms of interaction metadata, which we will introduce and explain in future tutorials once the fundamentals are clear. Interaction affordances also define data schemas that describe the structure of inputs and outputs. These schemas use JSON schema, as introduced in our preliminary series, to define data types, allowed values, and nested structures. In our example, the brew coffee action expects an input object with a size property, which must be either small, medium, or large. Any interaction affordance can also have structured data, regardless of its type. Here, the event low on water includes a numeric value describing the remaining water in milliliters. Similarly, the property coffee beans left specifies a number between 0 and 500, representing the grams of beans available. Data schemas are crucial for validation, tooling, and interoperability. So when you're authoring a thing description, make sure to clearly describe your data to ensure it can be interpreted correctly. That wraps up this tutorial. In the next video, we'll dive deeper into protocol bindings and learn exactly how to interact with a thing over the network.